We are on the sections 9.3 and 9.4, page 41. We talk about how to simplify the radicals, right? Last time. Then we are going to talk about add, subtract, multiply, and divide. So for adding and subtracting, just like your XYZ, other polynomials. Okay, so let's take a look how we do. So what do you think if we have 4x plus 3x? Automatically you will think what? 7x, right? Then how do you get a 7? You will subconsciously add your 4 and 3, right? So you use distributive property. So for those, like terms, what are like terms? You have same variable, right, with same power. Then you just put the coefficients together, right? So for polys, same variable, same power, you combine them, right? So if it's for subtraction, what do? You will do 7 minus 1 of the x, you end up with 6x, right? Then if you have 5x plus 2y or 4x plus 7x squared, can you put them together? No, right? So those cannot be combined because they are not like terms. So for the radicals, we do the same thing. Okay, if you have 4 square root 2 plus 3 square root 2, what do you think? You will automatically treat square root 2 same thing as your x. Then you will do what? 4 plus 3 of square root 2. Then you will do what? 7 of square root 2. This means multiplying 7 square root 2. Same thing as 7x, right? So same thing, we are going to combine like radicals. So we are going to combine like radicals. If they are alike, like those both are what? Square root 2, treat as your x. Same fashion, okay? What kind of things are same as, like, we call it like radicals? Here is variable, same power, right? For radicals means what? The inside are the same, like square root 2 and square root 3. They are not like radicals. So inside supposed the same like your variable, okay? If you have a square root 2 and cube root of square root 2, one is cube, one is square. They are not like radicals. So it means what? The inside like your x, the outside like your power, okay? So those things we call index. So you have to have what? Same radicand and same index. Okay? So radicands is like your variables, right? Then index is like your power. So power is, we call it exponent. Then opposite would be what? the radicals. Instead of taking the power, multiply how many times, then we take a radical, means what? Take a root, opposite, right? So same thing for subtract. If you have 7 square root of 5 minus square root of 5, it's like here. Square root of 5, it's like your x. And 7 minus 1, right? For square root of 5, so the answer is what? 6 square root of 5. Okay? And if we have situation like this, if 5 square root of 2 plus 2 square root of 3, then those are not same or like radicals. So same thing as 4 square root of 2 and 7 cube root of square root of 2. Those things cannot be combined. So we operate under those situations. If they are like terms, then we simplify them and subtract, right? So let's take a look some examples. So if we have square root of 18 plus square root of 8, do we have like terms? Not really. However, do we leave the terms as such? No, because we have to follow the rules, right? 4 rules to make the radicals as simple as possible, make the inside as small as possible, before we can decide if they are like terms or not, right? So we need to clean up. To do this one is what? 2, 2, no, 2, 3, 3. You do your trees. So you have what? The root for the square, root of square. You take outside, right? Become 3 square root of 2, right? Then this one is 2, 2, 2. So you have a twin, you take outside the radical. So you have 2 square root of 2, right? Then, do we have like terms now? So that would be what? 5 square root of 2, right? Then, if we look at 3 square root of 50 minus 7 square root of 12 plus square root of 32. Do we have like terms? Not right now. So we need to clean them up, right? To simplify each individual one. So your problem is not combine like terms like your x, y, z. Your problem is what? Simplifying. Okay, to decide if they are simplest form or not before you do anything. So this one will be 2, 5, 5. Right? So you take this out, that would be what? That would be, for this one, would be 5 square root of 2 for square root of 50, right? Then don't forget you have 3 outside, you need to write it. And for this one, will be 2, 2, 3, right? Then you take this out, that would be what? That would be 2 square root of 3. Then you have 7 outside you need to multiply with. Don't forget your coefficient outside you need to multiply together. Okay? Then for this one, that will be 2, 2, 2, 2, 2. Do your trees. So that would be this and this, twin, right? So that would be 2 and 2, that would be 4 square root of 2. So first you simplify them, right? So what do we have? So this one is what? 15 square root of 2 minus 14 square root of 3 plus 4 square root of 2, right? So we have like terms. That would be those. So that would be what? 19 square root of 2 minus 14 square root of 3, right? That's how we combine like terms. So first, remember to simplify them. Okay, so we add, subtract directly, just like those. So you simplify each individual term, then you decide if they are like terms or not, right? 3 is the simplest one. 24, it seems you can break down, would be what? 2, 2, 2. That would be 8 times 3, right? Take cube root of cubes, then every cube you need to take out. So this one would be what? 2 cube root of 3, right? So then you will have cube root of 3 plus carry down this 2, right? Then 81 would be 3, 3, 3, 3. So cube root. Take a 3 out. Then you have cube and this left inside. Then you need to carry this down. Don't forget your coefficient, right? Then what do we have? We will have cube root of 3 plus 4 cube root of 3 minus 21 cube root of 3, right? Now do we have all the like terms? Invisible one here, you have 1 here, plus 4 here, 5 of them, minus 21. So that would be negative 16 cube root of 3. That would be your answer. Right? Then for x and y's, we will do the same thing. Okay? 20x squared plus square root of 45 x squared. Then we take a look. Then 20 is what? 2, 2. That's 4 times 5 x squared, right? So that's the square, that's the square. So you have 2x outside, square root of 5 inside. And you carry down this 2, right? Then plus here, 45 would be what? 3 times 3 is 9 times 5 and x squared, right? So that's the square, that's the square. So you have what? 3x outside, square root of 5 inside, right? Then what do we have? We have 4x squared of 5 plus 3x squared of 5, right? Total, what do you think that would be? That would be 7x squared of 5, right? 4x plus 3x is 7x. Then, if we have m squared of 72 minus square root of 200m squared, we will do the same thing, okay? So, what do we have is, break down this, 2, 2, 2, that's 8. 8 times 9, so that's 3, 3. You do your trees, okay? So that's the square, that's the square. Take them out. 2 times 3 is what? 6 square root of 2. So that would be your square root of 72, right? So carry down your m. That would be that one. Then for this one, 200 is what? 2 times 2, 4 times 2, 8 times 5 times 5. Let me see. 25, 50, 50 times 4, 200. Yes. Okay? Then you have m squared here. So that's your twin, that's your twin. You show the root of square, that's 2 and 5, right? Then also you have m here, right? Square is m as a base, as a root. So you have 2 left. So that will be this way, right? You change that to this thing. Then what do we have? We have 6m square root 2 here, right? Minus 10m square root 2. So what do you think this will be? 6m minus 10m is what? Negative 4m, then square root 2. That would be your answer, right? So add subtract is not a problem. So all you need to do is you have to simplify them first before you can decide if you have like terms or not. Okay? Then we do multiplying. So multiplying is this, right? If you have same power, same index actually, right? So same radicals. So you have in this way, right? Different, just like your x and y. Then what do you do? Multiply, become xy, right? So what we do is, if they have same index, we can put them all under same roof inside, okay? Or we can split them. But when we do the multiplication, we will put them together inside as, multiplied number, okay? So don't forget that somehow you get confused with how to multiply the radicals. The whole thing is you have to have same indexes so they can be split or they can be combined, right? So if we do this one, do we have same radicals? Both are square root, right? So we should be able to put it together. 4 times 5 is 20. So both are square root. So we can put them together, 18. Do we leave answer there? We need to do what? Simplify, right? So this one will be what? 2 times 3 times 3, right? So you take that out. So what should you have? You should have 20 times what? 3 square root 2, right? Then you multiply them together for the number part. So that would be 60 square root 2. Okay, that's how you multiply things. If they are same index, you can combine them or you can split them. So if we have square root of 5y times square root of 15y, should we put them together? Both are square root, right? So you have 5 times 15 is what? 75 and y squared. Then you break down the 75 will be what? 3 times 5, 15 times 5. That will be 75, right? So y squared. Then you take the root out. Square root, root of square. So that's the root will be 5 and y will be what? 5y outside square root of 3. 3 left inside. Right? So if we have this one, square the root of 5 times cube root of 2. Can we put 2 and 5 together? No, we cannot. Right? So we will not do this. Skip for now. For those multiplication, if we multiply those radicals with what? With the different indexes. Okay? You probably will do this kind of thing in pre-calculus, so not in algebra class for you. Okay? So we are just multiplying radicals from what? One term times one term, right? So actually, this one is what? Mono times mono, right? Okay, one term times one term, then we use what? Product rule to do that. First, you put it together inside by multiplying. Then what do? You simplify them. Okay? Then what happens if we do more terms multiply together? If we do mono times poly, okay? Here is one term times one term. If I do mono times poly, one term times many terms, right? Just like your algebra XYZ, the way we multiply, we need to do what? We need to distribute them. We use distributive property, right? So if we have this way, one term times what? 3 square root of 5 minus 7, right? Two terms. So what do? We distribute them. So you have what? A times 3 square root of 5, right? And A times 7. So for first term, A times 3, 24 square root of 5 minus A times 7, 56. Can we simplify them anymore? Don't combine them because you have two terms. Are they alike? No. So they are not like terms. We cannot combine them. Okay, remember that. And same thing, if I have square root 3 square root of 6 times what? 4 square root of 2 plus 2 square root of 3. So what do we need to do? We need to distribute, right? So you have 3 square root of 6 times what? Okay, 4 square root of 2, right? So you have these two multiplied together and plus 3 square root of 6 and what? 2 square root of 3 multiplied together, right? So becomes what? Mono and mono. Then you can put it together. So 3 times 4, 12. Then same thing as square roots. So you can put it together 6 times 2. Right? 12. And for next one, 3 times 2 is what? 6 for the roots. 3 square root of 6 and square root of 3. That would be what? The root of 18. Right? Then, are we done? You have to check. So, for 12, that would be what? 2, 2, 3. Right? So, that's your root. So, you have what? 12. This one is what? 2 is the root. take outside, square root of 3, right? Then this one is 2, 3, 3. So that 3 is the root of square. So you have what? 3 square root 2, 6 outside. Right? Then we'll combine. We cannot combine them. We have to figure out if we can combine them or not. So that would be 24 square root of 3 plus this one would be 18 square root of 2. So are they like terms? They have different inside radicals. So we cannot put them together. Right? So that would be your answer for that one. To the simplest form. Inside the radicals, and should be as simple as possible. Right? So we did what? One term times one term. Here, one term times many, many terms. Right? We also do what? Binomial times binomial. 2 terms times 2 terms. Then we should use what? FOIL. Right? Distribute everything. Then, let's see. First one, square root of 3 minus 2 times what? Square root of 3 plus 5. Right? So you need to write it out individually. Okay? So first will be what? Square root of 3 times square root of 3. Right? Then outer will be what? Just write it out. Positive square root of 3 times 5. Right? Then next inner become 2 times square root of 3. Right? Then last become what? 2 times 5. Right? So each term is separated by your what? Plus minus sign. So, right? They are separated. And 2 terms times 2 terms, you have 4 terms right now. 1, 2, 3, 4. Then we have to figure out if we can combine them or not. Right? So square root of 3 times square root of 3 is what? Square root of 9, which is what? 3. Right? Then 5 times square root of 3, just 5 square root of 3. Like x times 5, 5x. Right? Then minus 2 square root of 3, this one is what? Minus 10. Now, do we have like terms? Yes. Number and number, right? 3 minus 10 is negative 7. And for the like terms for the radicals, 5 minus 2 is what? 3. Positive 3 of what? 3 of square root of 3. Right? Okay. Next one, if we have 2 square root of 10 plus square root of 6, take square. Right? What does square mean? It means what? It times itself. How many times? 2. Right? Then you need to do FOIL. So you write it out. Don't do it directly. So you write it out so you have less mistakes that way. So you do what? First one, 2 square root of 10 times 2 square root of 10. Right? The next one becomes what? 2 square root of 10 times what? Square root of 6. Right? Then the bottom, you will have plus square root of 6 times 2 square root of 10, right? Plus square root of 6 times square root of 6, right? So 2 terms times 2 terms, you have 4 terms. You'll be fine. But next step, you make mistakes, okay? So we say mono to mono, when you multiply numbers with numbers. 2 times 2 is what? 4. What happened to the inside? You have same thing as a square root. Then you should put them together inside, right? 10 times 10 is what? 100, right? Then plus this 2 outside, square root both. So 10 times 6 is what? 60, right? Then same thing for this one. 2 outside, you have what? 60 inside, right? Then plus, you make a mistake here. Some of you will just write the square root of 6. Don't do that, okay? Because you have same radicals and both are square root. You need to multiply the inside, right? So what is square root of 100? That's 10. 4 times 10, right? Then plus, do you leave 60 there? You need to simplify. Okay, so 60 is what? 2 times 2 is 4 times 3 times 5, 15, right? Right? So 2 has to be outside, so become 2 times what? 2 outside and 15 inside. Is that right? This is the same thing for that, like here. So it will be 2 outside, 60 will be 2 and square root of 15, right? Then square root of 36 is what? It's 6. So what do we have? We have 40 here plus 2 times 2, 4 square root of 15, plus another 4 square root of 15, right? Plus 6. You simplify them. Then you combine like terms, okay? 40 and 6 would be what? 46 plus 4 and 4 would be 8 of what? Square root of 15. So that would be your answer. Right? Okay. So when we do mono to mono, same radicals, then you just put it inside together. Okay? Mono times many terms, you do it individually. Same thing, bino times bino, you have to do it individually. Write them out first. Become mono and mono. Then for same radicals, then you have to multiply the inside. Okay? Take a look. Next one, square root of m plus 5 times square root of m minus 1. Okay? So, let's see. Two terms times 2 terms, we should have 4 terms, right? So we distribute, then m square root of m times square root of m, right? First one, then next one will be square root of m times 1, right? Then this one will be 5 times square root of m. The last one will be what? 5 times 1, right? Then square root of m times square root of m actually is what? M squared, right? Then this one is 1 square root of m plus 5 square root of m minus 5, right? See, when we multiply them, we end up with some numbers and with your radicals. Some number with your radicals. Then for this one, square root of m is m, right? And you have, then these two are like terms. Negative 1 plus 5 is what? Positive 4 square root of m and minus 5. So that's the simplest form you might have. You have, actually, right? So usually you will have some numbers plus radicals. And you have numbers, n is a number, right? Then phi is a number and some radicals, right? When you multiply. And somehow, next one is a little bit different when you have a situation like this. We have radicals here, we have a radical here, right? Binomial, binomial times binomial. What's the difference between this case? Those two numbers are the same, 2 square root of 5, 2 square root of 5, and 7 and negative 7. But one is plus, one is minus, okay? Let's see what happened. So we write it out. First one, 2 square root of 5 times 2 square root of 5, right? Next one, minus 2 square root of 5 times 7, right? Then the bottom one will be plus 7 times 2 square root of 5 and minus 7 times 7, right? Let's see. So become mono and mono, multiplying separate terms, okay? So 2 times 2 is what? 4. Then same radical, then same kind, then you can just multiply inside by the product rule. 5 times 5, 25, right? And this one, 2 times 7, 14 square root of 5, plus you have 14, another square root of 5, minus 7 times 7, 49, right? And what is square root of 25? That's 5, right? Become 4 times 5, right? Here, it's both square root of 5, but positive and negative. It cancels out. Then minus 49. Then what do we have? 20 minus 49, which is what? Negative 29, right? What happened to the radicals? When you multiply them, you distribute them. Oops. Radicals are gone because one is plus, one is minus. You end up with just a number. Okay, other cases, we all have radicals left. In this case, we don't, right? This is a special condition when you have a binomial, and 2 square root of 5 plus 7 and 2 square root of 5 minus 7, when they multiply together, one is plus, one is minus, middle terms canceled out. Then you only have a regular numbers left, right? So condition like this is a special case. We call these two numbers are conjugates. That means same number, but one is plus and one is minus, okay? So for instance, if I have a 3 minus 5 square root of, say, 7, what would be its conjugate? Opposite would be 3 plus what? 5 square root of 7, okay? So if I have, say, 2 square root of, say, 3, right? Plus, say, 3 square root of 7. What is its conjugate? Oh, we just need one of them. Become radicals. All right, so that would be what? 2 square root of 3 minus 3. So if you change the sign, then other numbers remain the same, then you will have conjugates. We need to have these conjugates concepts to do the division, okay? So we just did what? Add, subtract, multiply. combine like terms, then you multiply mono to mono individually. Then if it's the same radical, right, then you multiply inside, put it together. Then you simplify. Okay, so we just did what? Add, subtract, and multiply square root radicals for your sections 9.3 and 9.4.